In this video, we're going to be learning about the Poisson distribution. A Bernoulli experiment is one in which there can be a success with probability p or a failure with probability 1 minus p. In a previous video, we learned that the expected value of this experiment is p and the variance is p times 1 minus p. If we want to determine the probability of getting k successes through n Bernoulli experiments, we can use a binomial random variable, which is governed by the following probability distribution, with expected value n times p and variance n times p times 1 minus p. With the binomial distribution, we know nothing about time, but in many cases, time is important. For example, what if we're told that a success occurs every 5 minutes, and we want to know the probability of getting exactly 4 successes in 10 minutes? Notice that the metric we're given, which is 1 success every 5 minutes, does not tell us anything about the number of trials that will occur or the probability of a trial being successful. To solve a question like this, we need to use the Poisson distribution. The Poisson distribution is defined as lambda tau to the k, e to the negative lambda tau, all over k factorial. And it is derived by taking the limit as n goes to infinity and p goes to 0 of the binomial distribution. In this equation, k is the number of successes we're interested in. Lambda is the success rate per 1 unit of time, and tau is the total time horizon. In this example, we have 1 success per every 5 minutes. If we choose a minute interval time period, our lambda is 1 over 5. Then, because we're trying to find the probability of 4 successes in 10 minutes, our k value is 4 and our time horizon, tau, is 10. If we plug these values in, we get a total probability of 22%. Let's move on to another example. A customer service center receives phone calls at an average rate of 3 calls per hour. What is the probability that the center receives exactly 2 calls in a 30-minute period? Let's start by writing out the equation for the probability of k arrivals occurring in tau time for an arrival rate lambda. From the question statement, we know that the arrival rate is 3 per hour. The time horizon defined by the question is 30 minutes. We need to convert this to be the same units as the arrival rate, so tau equals 0.5. Next, we're interested in the probability of receiving exactly 2 calls, so k equals 2. If we sub these values into the equation, we can easily compute the probability of there being exactly 2 calls in 30 minutes, which ends up being 8.4%. Another important fact about the Poisson distribution is the mean of the distribution and the variance of the distribution are equal to lambda tau. So the expected number of arrivals in any designated time period tau is given by lambda tau. In short, in this video we learned about the Poisson distribution, which governs the probability of k successes occurring in time horizon tau for an arrival rate lambda, and we learned that the expected value and variance of this distribution is equal to lambda tau. Thank you for watching. Subscribe to the channel for more content on probability, logic, and beyond.